All right, my sixth grade friends. So this will actually end up being the final video of the year. Thursday, May 21. Next week is just the book review and the chapter 9 review, so there's no new videos. So this is going to be our final video today here, focusing on linear functions. So our first set of directions tell you to copy and complete the table, then make a graph of the data, write an equation for the function. All right, so they're going to give you a function, which in this case we're going to use find the cost of renting ice skates for H hours at $5 per hour. So we're going to write an equation. The idea is that it costs $5 per hour. So our equation would actually work out to be C, which is what is represented by the cost, equals 5H. 5 times the number of hours equals the cost. So that's writing an equation for the function. You'll need to write that down. Then you're going to use this equation to fill in the table. You're going to have to copy the table down in your paper as it is, but then you're going to have to fill in this missing information based on this equation. Well, we know that the cost equals $5 for every hour. Well, for 1 hour, 5 times 1, the cost would be $5. For 2 hours, 5 times 2, the cost would be $10. For 3 hours, 5 times 3, the cost would be $15. For 4 hours, 5 times 4, the cost would be $20. All right? And so we take a look at that there, and that's our table. Now it tells us to make a graph. Now, depending on your assignment, whether you can use the graphs that I've provided, these numbers are going to be too big. That's why I use this example. So in case you need to make your own graph, you can do something simple like this. All right? And I'm going to kind of show you. All of my numbers are positive, 1, 2, 3, 4, 5, 10, 15, 20. You'll be using just positive numbers too. So you can kind of make something that looks like this. Here's my y-axis, there's my x-axis, and there's 0. Now, this will be my cost, my hours down here, sorry. 1, 2, 3, 4. All right, that'll be my cost. And so what I'll kind of do is I'll make a line straight up as neatly as possible for each of these. All right, and then I will have my cost here, and I'll go 5, 10, 15, 20. And then I'll graph the points, all right, for when the cost for when that's just 1 hour, sorry, the cost is $5. So it's going to go right there. When it's 2 hours, the cost is $10. So it's going to go right there. When it's 3 hours, the cost is $15. So we're going to come right here. For 4 hours, the cost is $20. So we're going to go all the way up to the top. And then it is a linear equation, so it would make a straight line. And the idea is it would keep going forever in both directions. And that's what you'll do on that first part. Now, the second part is pretty self-explanatory, and I'm going to just show you some examples here. It's going to be showing you graphs with different lines and different things going on, and it's simply going to ask you, does the graph represent a linear function? Well, if it's a linear function, there's a line. Linear is spelled L-I-N-E-A-R, and line is just L-I-N-E. So you see the word line in linear. If what you see in the graph is a straight line, then yes, it is a linear function, and all you have to write on your paper is yes. If it is not a straight line, then no, it is not a linear function, and all you need to write is no. So I look at this example. This is a straight line, so this would be a yes. It is a linear function. I come down to this one. Well, I see my line here. Almost looks like a mountain range. That is clearly not a straight line. So that would be a no. I go to this one right here. Oh, yeah, this is a straight line from here to here. This would definitely be a yes, a linear function. This one here, well, it's a nice curved line, even if I do so say so myself, but it is not a straight line. Thus, that is not a linear function. That would be a no. All right, the last part of your assignment today asked you again a yes or no question. Does the input-output table represent a linear function? Explain. Now, on that previous part, I don't need you to explain. I kind of explained the difference. If it's a straight line, it's a yes. If it's not a straight line, it's a no. It's the same thing here. Does the input-output table represent a linear function? Explain, yes or no. If I were to graph this, if it's going to be a straight line, then yes, it's going to be a linear function. If I were to graph it and then it were not a straight line, then it would be a no. It would not be a linear function. But I want to show you how you can tell if it's a linear function or not without graphing it. I don't want you to have to graph these. You look at your input, which is your x value. You look at your output, which is your y value. And if you see a consistent pattern, okay, like 3, 4, 5, 6, all right, and I see a consistent pattern happening there, and then I look at my y pattern, 8, 7, 6, 5. Well, I see in my x, it's going up 1. I see in my y, it's going down 1 every time. That is a consistent pattern. Thus, this would be a linear function. If I look at my second one here, in my x, I'm going 1, 5, 9, 13. Well, I notice that I'm adding 4 every time. 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13. Then I look at my output, and I'm going, well, 2, then 5, then 5, then 2. It's not a consistent pattern, okay? Thus, if I were to graph this, it would not be a straight line. And that's how you can look. I don't need you to graph those. I just need you to look at both the x and the y. If it is a consistent pattern in both the input out and the output, both x and y, then by a pattern, I mean it's consistently doing the same thing from one number to another. A pattern would not be add 1, add 3, add 1, add 3, add 1, add 3. That would not be considered a linear pattern. It has to be the same thing every time, like this. You're adding 1. Or here, you're subtracting 1. And since there's a consistent pattern in both, that's a yes. Well, we have a consistent, and just to review number 2, we have a consistent pattern in our input here. 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13. But we do not have a consistent pattern in our y. We're adding 3, then it's the same, then we're subtracting 3. Not a consistent pattern. This would not graph as a line. All right, have a great day, 6th grade. Hope you enjoyed and learned something from our last video of this school year. Talk to you later. Bye.